Hello, good day everyone. Welcome once again to our session. Today we are going to continue our discussion on the topic of integration by substitution. So last time we talked about integration by substitution on the topic of rules or the chain rule for anti-differentiation. Okay, and we also have integration by substitution for uh, trigonometric functions. Okay, so today we are going to discuss this other scenario, integration by substitution. So in this case, class, we will discuss integration of exponential and logarithmic functions, and we use the substitution method to solve those types of integral functions. All right, so we have here the rules for integrating exponential functions and functions shielding logarithmic functions. So these are the concepts, class. So the exponential rule is something like this. If you're given an integral of exponential function with the exponent k times x, then multiplied by dx, so this is just equivalent to e to the power k times x divided by k plus c for all x not equal to 0. Alright, so the condition here, x must not be equal to 0, because if this is 0, of course, if this is 0, 0 times k is 0, so e to the 0, that is equal to 1. Okay, so for if that is equal to 1, so times dx, so you're just integrating dx, which is equal to x plus c. Alright, so that's the condition, class. Or if you are given something like this, the base here is b, unlike in the first scenario, we have E. E is equivalent to 2.7182818. But here we have another base, so any value here except for E, this is B. So raised to a power or exponent kx times dx is equal to b to the power kx divided by k times ln b plus c. So for all x not equal to 0. All right. So these are the two scenarios that we can integrate using the rules or the rules for integrating exponential functions and functions yielding logarithmic functions like this. Okay, so integral functions that yields logarithmic functions. So ln here is a logarithm with a base e, natural logarithm. Okay, so if u is a differentiable function of x, then we have this integral of e to the power u times du is equal to e to the u plus c. Alright, so this is a very simple and yet a very important formula for exponential functions, class. So you have to remember this. Then another one is integral of b to the power u times du equal to b to the power u divided by ln b plus c. Alright, so these are just taken from these two formulas above. This is now using the substitution, so we come up this new formula. Okay, so for example, if you are asked to evaluate the following integrals, number 1, e to the 2x plus dx, integral of e to the 2x plus 1 times dx. The other one is integral of 2 to the 3x dx. Number 3, so you have this, and number 4, you have this. So you just apply that formula and you can easily solve this. I will make another video class to show you the detailed solution of each of these examples. Then we have here rules for integrating exponential functions and functions yielding logarithmic functions. So the logarithmic rule. So a while ago we talked about exponential rule. Okay, so we have here exponential rule. This is the exponential rule. So you use this formula for the exponential rule. Now, if you are given the logarithmic, then we also have the logarithmic rule. Logarithmic rule. This one. So what's the logarithmic rule? Okay, so another formula that you need to remember. So 1 divided by x times dx is equal to ln of the absolute value of x plus c for all x not equal to 0. Now, if u is a differentiable function of x, then we have this 1 over u times du is equal to ln of the absolute value of u plus c. Okay, so we have also some examples here that we need to solve. I will make another separate video for this part class. All right, so that's all, and just see you in our next videos. Okay, bye. Thank you very much.